is why the letter is E. Okay? So that we know who did it. Kind of he found it, so he gets to name it, and of course he named it after himself. Okay? All right, so it's a series. It's 1 plus 1 over 1 plus 1 over 1 times 2 plus 1 over 1 times 3. This is called arithmetic series, and we're going to get to arithmetic sequences and series later on this year still. Okay? All right. So E is your base, and it represents an exponential growth or decay that's continuously occurring. Radioactive material decays continuously. It never stops. Okay? Something that grows continuously. Rabbits grow continuously. Fruit flies. That's why fruit flies are used, because they can grow. They have a very short lifespan, but they grow rapidly. So you can see what's going on when you're doing tests. Okay? So here's your general formula for a growth or a decay that is occurring continuously. And so you've got some new terminology to look for. When you've got a continuous, this is what you've got. If you've got it compounded, then you go to your other formula, all right? The compound formula. So a compound, if you see the word compound, it's going to be A sub naught 1 plus R over N to the NT. That's your compound formula. If you just see it's a growth or a decay, without any of those fancy words, it's simply A sub naught 1 plus or minus R to the T. Well, it just means you're beginning at 0. That's what they call it. All right, so then we're going to look at we're going to identify these values. If R is what's R going to be? Your rate. Okay. T is your time. And A sub naught is your beginning amount. Okay. And if A sub naught is less than 0, where are we going to fall? Under the asymptote. And if A is greater than 0, we are above. Okay. Growth and decay, we look at something else to determine if it's a growth or a decay. If this is initially positive, it's a growth. If this is initially in the equation negative, it's a decay. So it's not the base. It's not E. E is a value. It's fixed. Unlike the ones that you did on the board, your base could be any number. It could be 2 or it could be a half. But this base, when we deal with natural logs, is only E. So we look someplace else to find if it's a growth or a decay, and it's up in the exponent. Okay? Make sense? So it'll say, this is compounded quarterly, or this is compounded continuously. So continuously, yes, continuously you use this. Compounded quarterly, annually, semi-annually, you're using the one that we were. Do you understand now? So you've got to really look at the words. Okay? Sometimes you see it as PERT. Correct? That's the other way that you see it written. This book has the other formula, which is renames P instead of A sub naught. Yes? Absolutely. Everything in this chapter you've had. Okay? All right, so compare the bounds after 10 years of a $5,000 investment earning 8.5% interest compounded continuously versus compounded quarterly. So here's an example, Maggie, of knowing which formula you want to use. Agreed? This one continuously means I'm going to say that my end amount is equal to my beginning amount of $5,000. E is our base. Our rate is what? What am I going to rate? .085, and then my time is 10. Do you remember where to find E on your calculator? It's the LN key. It's your second LN key. Okay? So plug it in. Oops. E is that 2.78. It's that arithmetic series. It's irrationals. So second ln gives you your E function. And then .085 times 10, close your parenthesis. So I get $11,698.23. This whole thing. E to the .085 times 10. It has nothing to do with radians. Try it again. Let me watch you put it in. $5,000. Oh, see, here's your issue. You raised it to the .085, got an answer, and took that answer and divided it by 10. You don't want to close your parentheses? Yes, that's what you want. Okay? Right. Okay, compounded quarterly, A will equal, what am I going to write? 5,000 Yep. Yes. Okay. Because quarterly, compounded quarterly is a different formula. Because we want to see the difference and how much you make. And so .085 divided by 4 plus 1 to the 40th power, right? Times 5,000 gives me 11594.52. So, which one gives you a better deal? Well, they're both 10-year. Continuously. By how much? You don't think? By about $103, isn't it? I got 103.71. So, you know what? I took this, but I kept this in my decimal form, so that's probably why it's a little off. So, you know, maybe not that much of a difference, but if you are putting away your life savings as you, huh? Now, who eats for $103? For $103 a week? I'm at $250 a week. It is nuts. Maybe about 5 years ago, but yeah, I was gonna say my kids are eaters now. They're just growing. Do you guys eat out? Oh, okay. That's because your mom's gone, right? Isn't that what you said? Yeah. Okay, are we good on this one? All right, so let's look at the next one. Why do we do 4? Because it was quarterly. Quarter. How many quarters? Well, right? Got to read it. All right. The population of Dubuque, Iowa declines at a rate of 0.4% between 1997 and 1998. In 1998, the population was that amount. Let t be the number of years since 1998 and write a function to model the population. I don't know, is it? Well, think about it. What do you think? If it's a decay, I need to do this as a decay model. Right, this doesn't say continuous, but it is declining. So to me, that's 1 minus 0.004 becomes my rate. Wouldn't you agree? Okay, and so how much do I have initially? 87806, and so really I have 87806, and what is 1 minus 0.004? Oops. Yeah, 0.996, and then, well, they said write a function of the model, right? And so this is going to equal my y value or my p. So suppose the rate of decline remains steady. What's the projected population? So in 2010, so what do you think, what is your t going to be? $19.98.
No, they want 2010. No, it is
12, right? I was wondering how you got 14 out of that. Okay, so 0.8. So 87806.996 to the 12. Well, the birth rate's going down. People leave, get different jobs, because it's Iowa. There you go. That's what I got. Is that what y'all got? Okay. I think that's the last one, isn't it? Whenever you got compounding going on. Never did that word appear.